Hello, today's lesson is 3.1 solving equations. Go ahead and put the date. And our goal for today is that I can solve one-step equations. As you can tell, format for this one's a little bit different again. I can't be seen. I'm on audio alone. We'll see if this helps in some of the delay. That we're going to be solving for a variable in these first couple, okay? So we're solving equations for a variable, and when we solve for a variable, our goal is to isolate. Now, isolate means get the variable by itself, okay? So isolate the variable on one side of the equal sign. So we're going to be concentrating on getting the variable by itself. And here is our first example. So for our examples, we start out with m minus 48 equals 29. Now, I know in the past you might have solved these equations a little bit different, but for today and for the rest of the year, we're going to be solving the one-step equations that are being added or subtracted by transposing. So, our goal is to isolate the variable. So, we're going to say our variable is m, and we're going to ask ourselves what's happening to m. So, if I need to keep this guy, who do I need to get rid of? I need to get rid of my minus 48. I'm going to transpose him. So if he's a minus 48 on the left side, and I take him over here to the right, he's going to be a plus 48. So he disappears from the left when he goes to the right. I drop down my m because he's who I want to keep. He's who I want to get by himself. And I just add 29 plus 48 will give us 77. Alright, and what we're going to do is follow our instructions. It says to not only solve, but also says then check. So, I'm going to come down here just below it and do my check. Make sure my answer is correct. And we always go back up to the original, so m minus 48 equals 29. Now what we're going to do is replace m with 77. So m is 77 minus 48 equals 29. And now we solve out the left side, make sure it checks. So 77 minus 48 is 29. 29 equals 29. So we check. Our answer is good. Our answer is m equals 77. If you've noticed how I've boxed it in, be sure to do that with yours as well. That way it makes it easier to see the answer. Okay, for our example 2, we're once again asked to solve the equation. And our equation is 142 plus d equals 97. And then we're also asked to check it. So what we're going to do first is locate our variable d. And we have to ask ourselves what's happening to him. So if he's being added to 142, we then have to say, well, if I want to isolate my d, so if I keep him, who do I want to get rid of? I want to get rid of my 142. Now if he's positive on the left side, and I take him over here to the right, he's going to be a minus 142. So he disappears, and my d equals 97 minus 142 is a negative 55. I'm sorry, it's a negative 145. It's off there. So d equals a negative 45. So I have my d, he's all isolated, and now we do the check. So we go back up to our original 142 plus d equals 97. Now I'm going to replace d with a negative 45, so 142 2 plus a negative 45 equals 97. So now we know that different signs, a plus and a negative, are different, so we get just a minus. So 142 minus 45 is 97. And 97 equals 97, so we check. Now, that gets us through the transposing ones as far as giving us the problem. The next one here gives us a sentence and wants us to write it as an equation and then answer it. So example 3 says a number. So if it doesn't tell us the number, that means we get to use a variable because I don't know what that number is. So I'm just going to use the variable x. And it says is increased by. Increased by means we need to add 5. And it says is equal to. So that goes and tells me I need to use equal to 42. So we still look to isolate our variable. I have an x here, and then my plus 5. So if I keep my x, I need to get rid of my plus 5 and make him a minus 5 over here. So my 5 disappears, and I get x equals 42 minus 5 is 37. Oh, there we go. So those are our transposing ones. Whenever you're adding or subtracting a number to a variable, you need to transpose. Next, we're going to look at for when we're multiplying or when we have to divide to solve for a variable. There we go. Divide. Fix this for a little bit. To solve for a variable. Whenever we're going to multiply or divide to solve for the variable, we're going to have to make sure that we do the opposite of what is happening. I'm sorry, you have to do the opposite of what is happening to the variable to both sides of equation. Okay, so to multiply to solve for the variable, you need to do the opposite of what's happening to the variable to both sides of the equation. Once again, our goal is to isolate the variable to get it by itself. Okay? So we're given these and we're asked to solve and check. So for our example 4, we're given negative 6m equals 42. So you got to look right here and say negative 6 is right beside your m. So if they're side by side, they're being multiplied. So the opposite would be to divide both sides by negative 6. Negative 6 is cancel. M equals negative 7. We're also asked to check this. Okay, for our check, once again, go write our check. And we're going to go back up to the original. Oops. Sorry about that. My marker seems to be writing without me. There we go. So, negative 6m equals 42. Except this time we're going to place m with negative 7. So, negative 6, if they're side by side, they're being multiplied, so times negative 7 equals 42. So negative 6 times negative 7, two negatives make a positive 42. Positive 42 equals positive 42. We check. Alright, now up here at number 5, it says t over 30 equals 7 over 10. So even though we're dealing with fractions, we still just want to worry about just the variable. So our variable's t. That fraction bar means divide, so if t is being divided by 30, we need to multiply, and we show our multiply using our parentheses. So we're going to multiply both sides of our equal sign by our denominator of 30. We're being divided by 30, so we need to multiply both sides by 30. So 30's cancel, and t equals 30 times 7 over 10 gives us 21. Okay? And then if we go and do our check, once again, we go back up to the original, t over 30 equals 7 over 10. And we're going to replace t with 21. And this is where you can use decimals, or if your calculator will reduce down to the fractions. Both ways will work. So if we say 21 divided by 30, that'll give you a decimal 0.7. And if you do 7 divided by 10, that will also give you the decimal 0.7. So we check. Our answer is correct. And our very last one is example 6. And it says 1/6W equals 33. So I know it's a fraction, but if our fraction's right beside our variable, if they're side by side, that means they're being multiplied. So we need to divide both sides by 1/6. So our 1/6 cancels, and we're left with W equals. Now if you put this in your calculator, what you need to do is wrap this in parentheses. Alright, so 33 divided by parentheses 1 over 6, close your parentheses, and we'll get 198. And last, check. Once again, we're say 1/6 times W equals 33, except we're now going to replace W with 198. So 1/6 times 198 equals 33. Place that in your calculator if you need to. You can do 1 times 198 is 198. 198 divided by 6 gives us 33. And 33 equals 33. So we check. And that finishes up us for one-step equations in chapter 3. Thanks.